Now we can continue our discussion of experiment number 4, where we are discussing large sample test for proportions. So in my previous video, I have discussed these two examples wherein the single sample is there. See the example number 3. So in a simple random sample of 600 men taken from a big city, 400 are found to be smoker. In another sample means there is one more sample. So this is the example of two sample where 90 men taken from another city, 450 were smoker. Means in one sample 1600 men were taken, out of which there are 400 smokers, and in another sample 900 men were taken, in which 450 were smoker. So do the data indicate that there is a significant difference in the habit of smoking in two cities? So whenever we are interested in knowing whether the the data or the sample supports that the habit of smoking in the two cities were different or not. So to test this, what we need? So we need the procedure of two samples. So what is my aim in this case? Aim is to test whether there is a significant difference in the habit of smoking in the two cities. H naught is P1 is equal to P2 for the given sample. So what is the formula for this? The formula is Z is equal to P1 minus P0 divided by square root of P1 Q1 divided by N1 plus P2 Q2 divided by N2 follows normal 0 1 for large N1 and N2. But when both the proportion remains the same, we can reduce the formula. Instead of P1 and P2, since P1, P2 is equal to P, we can reduce this and use the formula as Z is equal to P1 minus P2 divided by square root of PQ into 1 upon N1 plus 1 upon N2. So which follows a normal 0, 1. Right? And suppose in case the value this P is unknown, P is unknown, it can be estimated from sample values. So P should be estimated like this, P hat, and this is Q hat. So these are the estimated values. And how to estimate these values? By using the sample observations. So P hat is x1 plus x2 divided by n1 plus n2, and Q cap value is 1 minus P cap. See, this Q cap is nothing but 1 minus P cap, right? What are the given values? See, there are two cities. One is city A, the another one is city B. So what is the sample size? Is 600 in the first case. The second case is 900. The number of smokers are 400. In the second one, 450. So therefore, we can easily estimate the sample proportion values. So what is the sample proportion value? Is x1 upon n1 and x2 upon n2. What are those values? So those values are P1 is equal to x1 upon n1. So that comes out to be 400 divided by 600 is 0.66. And the another case is P2 is 450 divided by 900. So that comes out to be 0.50. So what is my null hypothesis? P1 is equal to P2 versus P1, which is not equal to P2. So it is a two-tailed test. The level of significance is 0.05. If it is mentioned, then you can take the same level of significance. Otherwise, take this as 0.05. This is my formula. Put all those values. Calculate first P cap. X1 is known, X2 is known, N1 and N2 are also known. If you add x1 plus x2, that comes out to be 650, and n1 plus n2 is 900 plus 600. So that is 1500. The value now comes out to be 0.5666. Q cap becomes 1 minus P cap. So you can subtract this value 0.5666 from 1. What we are getting? We are getting this as 0.4334. Substitute all values and calculate the value of Z. So what is the calculated value of Z? Is 6.3815. So this value that I have also calculated from my software. And what we are getting? See, the value we are getting is, this is 6.3815. The same value we are getting, the calculated and also the value from my software. Next, what we are doing in this case, we need to find out the table Z, and I have shown you the value of 5% level of significance. So 0.05 divided by 2, since it is a two-tailed test, so that value comes out to be 0.025. If you see this value from 0.025, what we are getting? We are getting this value as 0.025. 0.025 is this value. See, I am taking this value from this value. So the value is 0.0256 value, and the corresponding value is 1.9, and this is 1.96. 1.96. It is this value 1.96. So I will show you this value. So this value is somewhat like this. See this value. This is 0.250. So the value of Z in this case is minus 1.9, and in this case is 6. Minus 1.96 is value, and the area is 0.025, right? So likewise, you can locate the value of Z. Now, what is my calculated Z? So table Z I am getting as 1.96. So calculated Z is greater than table Z. Therefore, you can reject H0. And what is the conclusion? The conclusion is there is a significant difference in the habit of smoking in the two cities A and B, right? So now move towards the last example. In the last example, so that is example number 4, whether the observed proportion of opinion about abortion in male and female is statistically significant or not. What we are getting? So we know the values of x1 and x2, n1 and n2. So x1 is number of favorable opinion about abortion by males. And what is x2? Is number of favorable opinion about abortion by females. What we are getting? See, all these things are mentioned here. How many males are there? Sample size is there. Favorable proportion. And then calculate the value of this p hat pooled value. How we are getting this value? X1 plus x2 divided by n1 plus n2. And what value we are getting? We are getting this value as 0.564. See, the value is 0.564. Therefore, Q cap becomes 0.436, right? So H0 and H1 are known to us. H0 is P1 is equal to P2, H1 is P1 which is not equal to P2, calculated value of Z. What we are getting by putting all these values? We are getting the value as minus 1.40. And what is the table value of Z at 5% developed significance? Since it is a two-tailed test, the value is 1.96. Therefore, calculated Z is less than table Z, we can accept H0. Accept H0 means what? So accepting the H0 means we need to write in the conclusion part. See, I have calculated all these values, and I have given this page also to you. What is my conclusion? The final conclusion is the observed proportion of opinion about abortion in male and female is not statistically significant. Means there is no such difference between the opinion about abortion by male and female. So likewise, we can draw the conclusion by using the data. Thank you very much.